Greetings, saber fans. It's your old pal Megtooth Sith, and what we've got going on here is an install tutorial going into this saber. This is a Ultrasabers Kanan Jarrus Hilt, and we're actually doing a tutorial on how to install this with Proffie 2.2 and Neopixels. This is an install vid that I've promised for quite a while, and the thing about these lightsabers, every lightsaber is different. This lightsaber is different than most of the sabers I've installed in the past. Every lightsaber is going to have engineering issues that you're going to have to work around. There were some methods that I used on this saber because it had a 16mm switch hole that I was able to consolidate and merge some connections up high that on most sabers you cannot do that. But the bottom line is I showed how to do a rough install on this saber, including a recharge port, 2 switches, and a kill switch on the chassis. This also uses Hexx Sabers chassis that are available at his Etsy store at Hexx Sabers, and I'll include a link to Hexx Sabers. I'll include a link to this Ultrasabers. But some other videos that you may want to watch while you're at it is I've done more extensive videos on recharge ports, on lightsaber switches, and also on how to wire the Neopixel adapter. And watching all those videos helps, as well as watching my basic Proffie tutorial videos where you're learning how to program the Proffies, including the SD cards and smooth swings. And you know, the Rebel Armory and the open source Facebook group page are also really valid places to learn some more information. There will be tons of links posted if you expand the comments below, and off we go on this video. I hope you enjoy this video on this install. I want to talk a little bit about wire. It's important to use the right wire. This orange wire is traditional jacketed wire. This blue wire is PTFE coated wire, which is military spec. This is high temperature coating. Now I want to show you the difference. I've stripped both of these wires back. I'm going to dip this in solder, or flux, I'm sorry. And then I'm going to bring in some solder here. And we're going to tin this wire. Now, when I tin it, I want you to watch what happens to the jacket. See that jacket melt back? It makes a mess. It gets all melty. It makes a huge mess. PTFE wire, same thing. Dip it in flux. Here we go to tin it. And I'm putting my soldering iron right on that jacket. Nothing. It stays stripped right where I strip it. So PTFE wire, there's a couple of reasons why this gives you a huge advantage. Number one is PTFE wire, the jacket is much thinner. It is harder to strip. You need very good strippers to strip it, but the wire itself is thinner. This is 30 gauge PTFE. This is 30 gauge normal. So you can see the difference in the jacket diameter. So PTFE wire is much thinner. I get my PTFE wire from PowerWorks. I'll put the website down in the doodad on the video. So that's the wire I use. It makes life much easier, and you should use different colored wires for different components. I always use red for positive. I either use black or white for ground or negative. I use green for main switch, yellow for auxiliary switch, blue for speakers, and I try to use different colors if I have different accessories to hook up. That way, when all my wires are back in the chassis, I know what they all are, and you have your wiring diagram handy, so you know where that colored wire gets attached. It helps keeps things simple. You make all your wire the same color, and you're in trouble. But at any rate, that's the tidbit on wires. Next, I want to talk a little bit about chassis designs. There's a bunch of different chassis systems out there, and I'm going to show you several of them today, and that way we can iron out some of the issues that I've seen with a lot of questions. Number one, this is a custom Saber Shop MHSB6 chassis. The new version of this is 3D printed with a battery door on it, but this is the older version that's made out of Delrin. This is a 3D printed chassis from Hexx Sabers Etsy shop, which I'll also link in the description of this video. This is a Goth 3D Designs chassis off of Shapeways, and this is for a Graflex 2.5 lightsaber, and it's got a permanently installed battery. The problem with these Goth 3D chassis and the permanently installed batteries, particularly on Neopixel sabers, is once you run your battery down, because you can't swap it out because it's located in permanently mounted inside the core of the saber, you're out of business on that lightsaber until you recharge the battery in the external recharge port, which in this saber is located here in the aft end of the chassis. And this is the internal part of the chassis where the soundboard goes, crystal chamber here, and you know, your recharge port here, and the kill key is actually attached there. So this chassis, while it's a great chassis, it's a great looking chassis, it's a permanently installed battery inside the hilt, and that can cause some issues. So typically on most installs that don't want crystal chambers, to me these types of chassis, which are like the MHS V6 chassis and these 3D printed chassis, which you can get from multiple sources, you can even print your own if you have your own 3D printer, which I don't. This one came from Hexx Sabers, this came from the Custom Saber Shop. And I would like to talk about these two chassis because this lightsaber tutorial that I'm going to be doing on this Ultrasabers install is going to be utilizing this Hexx chassis. But I am also going to do a tutorial on how to use these MHSB6 chassis with an 18650 sled. The main difference in these two chassis is on the Hexx chassis, you have to use a battery spring and a battery connector, and you're going to connect them into the chassis. Once you connect the wires to these, then you're going to epoxy these into the chassis so they become a permanent part of the chassis, and then the battery will actually sit just like that, which we'll have another discussion on batteries in a bit. And then your soundboard, you know, you could see it before, the soundboard on this chassis will fit just like this. And I'll be putting TH shroud on both of these. On the MHSB6 chassis, the soundboard sits here. Your wire passes on these chassis are here, and on this Hexx Sabers chassis is here. Here, 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 here. And these chassis are also designed to hold the speakers. This is a 28mm Saber Essentials speaker in this MHSB6 chassis. I've not yet installed a speaker into this chassis, but we will. So typically the first thing we want to do is to set up a chassis, and I'm going to show you how I set up both of these chassis styles, and then we'll talk about wiring the rest of the saber. But to me, setting up the chassis is important. So you want to build a lightsaber. Let's start out with some tools. First things first is some Allen key sets. I always get a metric set and an SAE, an imperial set. The metric set, you can tell, it says millimeter. This one used to say SAE on it, but it doesn't because it's old. Number one. Number two, soldering iron. An ESD safe iron with temperature adjustable with a small tip. A lot of people want to buy these Weller irons, and while you may get away with this, it's not ideal for the small soldering you're going to be doing. Professional temperature adjustable soldering iron that's ESD safe is preferable. This one is Heiko knockoff. I use Heiko tips. Now, there is my soldering rework station, and it's temperature adjustable on the soldering iron and on the hot air rework station. That's ideal. You're going to need wire strippers. I use this kind for PTFE wire, but I also have a all-in-one stripper that I can use for normal jacketed wire. Set of needle nose pliers, they come in handy. Of course, a set of wire cutters. I also find hemostats handy, as well as tweezers and an X-Acto knife. The water tip wipes that most soldering irons come with aren't effective. You're better off with a Heiko with some copper mesh in there to clean your soldering tips off. It's important to keep your tip clean. You always want your tip tin, but you want to keep it clean. So that's where we're gonna start off on saber building. It was just a quick run through of some of the tools that I find I use most often. And the last tool I want to talk about, which is highly neglected often by new installers, is a good multimeter. I prefer digital multimeters, and multimeters help you evaluate a lot of things and diagnose a lot of problems, diagnose shorts. Multimeters are also handy in that you can read actual voltage on different items. So right now I'm going to connect the clips of my test battery to the multimeter, and you should see it display voltage, which you do. So I know this battery in this tester has 4.02 volts in it right now. So this battery is fully charged that's in my test battery. You can also use the multimeter to test for continuity, which it displayed out of limits there because I was still connected to voltage. But like if I want to see if something's making a circuit or if I have a short, it has audible continuity test. And you can test for shorts by probing different pads to make sure that you don't have connection where you shouldn't. Like if you have a stray wire that's touching two pads instead of all the wire being soldered to one, which you should see that under microscope, but sometimes you could miss it. The multimeter will not miss it. Before I fire any saber, I test continuity between the pads to make sure that I don't have continuity where I don't expect it to be. So a multimeter is indispensable. If you're building lightsabers without a multimeter and you don't know how to use a multimeter, you're making an epic mistake. You can save yourself a lot of headaches and a lot of trouble by purchasing and learning how to use a multimeter. This is going to be beginner stuff for me too, but we're going to set up this Hexx Sabers chassis, and so I've got my chassis components laid out. I've got my speaker, my kill switch, which I explained earlier, and I have the two battery contacts, which I have to glue in here. And I'm thinking about using E6000 to glue them in, and this is going to be my negative with the spring, and this is going to be the positive here. And I think I'm going to use E6000 to glue them in, but I think I'm going to tack it with hot glue, but I also have to solder my wires to these first. And then we also have to solder the wire for the speaker. So for my speaker, I cut some blue 30 gauge wire, and basically I'll need two links of this that's longer than the chassis, because I'm going to be twisting my speaker wires together, so I always cut them a little bit longer than the chassis. So I've cut one that's twice as long as the chassis, and I'll show you here. And then I'm going to cut this in half, and that's what I'm going to be wiring to my speaker. Now I use 30 gauge PTFE. Again, the brand and store I use to buy my wire I'll post in the comments of the video, but I use 30 gauge PTFE for that. We're also going to be wiring a kill switch, which our kill switch will set right in Jeff's chassis just like that. So that'll be our on-off switch. He's got a little spot set out for that in the chassis, so we're golden for that. So I guess right now the big thing is I need to go ahead and wire my wires to this. Now remember, the negative lead is going to go back through a hole in this chassis to the switch, and then I'm going to have a negative out of the switch going to the soundboard, and the positive lead I'm going to have sticking out here, because how I wire my positives might be a little bit different than a lot of other people do theirs, but I do something a little bit unique on my positives to clean up the mess. So the battery terminal negative will connect to the center leg of this switch, and then the negative out coming from this switch, sorry. So my battery, I'm going to get to a pointer where I can point. The battery negative will connect to the center pin, and my negative out to the board will connect to this outside pin. This pin will not be used. That way when my switch is thrown this way, it will complete the circuit between my battery negative and the negative wire going to my board. When I turn the switch off, the circuit is broken and electricity is not permitted to flow through these posts. This third post, which is closer to me on the camera here, will not be used, and I will cut it off. You can use the third post, and there's other more advanced applications which we could talk about using that third post on, but in this application I'm only going to be using 2 of the 3 posts. One to receive battery negative and one to give it out when the switch is turned on. So the first thing I'm going to do on speaker prep is I've got 2 speaker wires, and these are 30 gauge PTFE. Remember, the link to the store where I buy this wire is in the description, and I'm going to strip 2 ends. I'm just going to strip one end of each wire, and then we're going to be soldering these onto the speaker. So once I have the end stripped, I'm going to give them a twist, and then dip them in the flux, dip them in the flux, and now I'm going to butter up the ends just like that. And that one's got a strand, so I'm going to have to clean that up. And I have pre-tinned my wires. Now this one has a little strand on the end that I saw when I was buttering it up, so I'm going to cut that off. Now, here is our Smuggler's Outpost 4-watt speaker, and I put them in my helping hands like this, and then I grab my forceps and I'm going to put the wire in my forceps, and I'm going to solder onto that speaker post. These speakers, the polarity doesn't matter when we're just running a single speaker, so it doesn't matter which wire is positive and negative. And you can see that, you know, I'm using 2 blue wires, so to me it really doesn't matter. So now I'm going to hold the speaker on the other side. I'm going to put my other blue wire into my hemostats, and that wire is a little long, so I'm going to trim it. You don't want them a whole lot longer than the pads you're soldering them to. And I'm going to, oops, sorry, hit the camera there. And I'm going to hold that till the solder sets, and it looks like it's set, so we're good there. Now I'm going to move my helping hands out of the way because we're through with those. Now, this is a trick that Mad Dog does on the custom saber shop, and I'm going to put a spot of hot glue there on the back of the speaker, and that basically provides some strain relief for the speaker wires. And we're getting close to ready to install this into the saber, but I'm going to hold that until that dries. There's no sense in y'all watching that. Alright, I have a piece of 22 gauge wire here, and I'm going to strip the end of it, and I'm going to twist it, and then I'm going to dip it in my flux. And get some solder here ready to roll. And you know, normally you can do this in helping hands, but since I'm kind of filming around the camera, yeah, my soldering iron doesn't want to take solder. There we go. She's taking solder now. So that's buttered up. So my negative lead is buttered up. Now this whole thing is going to get hot when I heat it up, so I'm going to slide my helping hands in here, and I'm going to I think I'm going to scratch up this post a little bit here. And scratching up helps give the the solder some place to adhere to. I'm going to butter that up with a little bit of flux, and I'm going to pre-tin this negative battery terminal there, and I've got some solder on the negative battery terminal. And now I'm going to bend my wire in a way that it is going to match with that spot that I've got ready to roll, and then I'm going to melt that wire into the solder just like that. Now that's a pretty good joint, but I think I'm going to add a little bit of solder to it just to be sure. And that is definitely a good joint. Now I'm going to do the positive battery connector. So I've got a piece of 22 gauge PTFE red wire, and I always like to use red for positives, and I'm going to twist that wire, and I'm going to dip it, and I'm going to bring in my solder close to the end of the wire here, doing that kind of off camera, but I'll bring it back in. Now I'm going to tin that wire. There's a strand there I don't like, and I'm going to have to sacrifice my fingers to God a little bit here to get that fixed. Now I'm going to dip it back in flux. That strand got loose on me. I don't like strands hanging out. And I'm going to make sure that wire is good and buttered up, and it is. So now I'm going to scratch the back of this. And I'm sorry the camera's shaking around, but there's no good way to hold this thing. These are helping hands, by the way, and I don't think I talked about helping hands on my tool list in the beginning. And I'm going to put a little bit of solder in there, and then I think what I'm going to do is I'm going to put my wire through this little thing in the back, just like that. Looks like it's supposed to hold the wire. And I'm going to solder that baby in. Now you're going to see me solder like you're supposed to solder. There. Now my positive battery terminal is now soldered. Now I'm going to clean these up with some alcohol and a Q-tip to get the flux off of both of them, so the flux won't mess up the glue. So I've got a little bit of isopropyl alcohol on a Q-tip here, cleaning the flux off of there. And I'm going to do the same on my negative lead. And now they should take glue. That alcohol will evaporate, and I'll come back to the camera when I'm ready to glue these in. Alright, this is the first time I've ever used these battery clips, and this chassis didn't really come with instructions, so I've tried to fit it off screen. And I think what I'm going to do, this is not really very user friendly, because I kind of want it to go like that. So I think what I'm going to do is go ahead and get some E6000 out, and I'm going to butter up the back of this thing with some E6000. But I think I'm also going to tack it with some hot glue while the E6000 sets up. So I'm going to pull that in, and I want it to be to be about right there. Thing really doesn't want to really go where I want it. You know, I want it to be about right there, and it doesn't want to stay there. There. That was not easy. Now I'm going to take some of this hot glue to tack it in while the E6000 sets up. And I'll try to tack in the bottom once some of that hot glue sets up. I've never used these type of battery leads before, so this is a new experience for both of us. But the bottom line here is that, you know, we're prepping the chassis for install, and I have, you know, messed around with the battery on this thing, so I'm going to hold this until the hot glue dries. Alright, so the positive end is in, and now I'm going to put the negative end in, and I'm going to put my wire through that hole because we're going to get to our switch, and it looks like the negative end is going to fit a little bit better, I hope. I don't know if I got that positive end up high enough. Again, this is the first time I've ever used these type of battery terminals in a chassis, but it looks like I just have to bend that wire until I get that fitting down there like I want. So now I'm going to put some E6000 on the back of this, and I'm going to get it into place here, and then I'm going to tack it with some hot glue while that E6000 sets up. So now I've tacked it with some hot glue while that E6000 holds up, so I'm going to sit here and hold it until the hot glue sets. A hot glue gun, I didn't mention that. I try not to use a lot of hot glue, but there are just some instances in saber building where, you know, hot glue is the right tool at the right time. I mean, E6000 is a really good adhesive. There's not going to be a lot of pressure on these battery terminals, and the soldering job is good on the terminals. I just need to make sure that, you know, the terminals are in place good enough. You know, I mean, the battery's going to hold them in place, but I got to make sure they don't rip out when, you know, when you take the battery out. You know, that's the key thing, I guess, here. Sitting around watching glue dry. It's not a lot of fun. Alright, so my hot glue is dried. Now I'm going to put the battery in there, and maybe that battery will help the E6000. I really don't like how low that positive one is. I think we're going to have to raise that one up a tad. Looks like it needs to be sitting up. Of course, there is a handy dandy way to test this, but I think I am going to raise that positive one up. I'm going to strip both my lead wires and see what we got here. Just bear with me. So I'm stripping them off camera. The lead wires that I've installed. Now that I got a battery in there, I can hook a voltmeter on it. Here's another good use for a voltmeter. Switch it to 9 volts. Hopefully you guys can see that. And I'm going to connect the red to positive and the black to negative, and we'll see what we got here. 4.10 volts. So even though that battery connector seems a little high to me, we're still getting, you know, voltage through the connector, but I still don't like that. And I've also got to find a way to add a removal strip, but I think I am going to be moving this up. So I'm going to pry this off and move it up. I'll get back to you in a second. Okay, I've readjusted the battery contacts, and I put my voltmeter on my leads, and I'm reading 4. So if you remember earlier, we talked about these switches. So remember, I'm only using 2 legs of this switch, and this switch is going to set inside of there like this. So I'm actually going to take this outside pole off. I'm going to go ahead and cut off that outside pole so it doesn't interfere with us at all. I'm going to dip that switch, those switch legs, into some flux, and I'm going to butter both of those switch legs up, preparing it to receive our wires. So now the legs are buttered up. Now this is the negative wire coming from the negative battery post, and I'm going to feed it in through the switch hole where it's going as tight as I can get it. And I want to leave enough wire to work with, so I'm probably going to cut it about right there. Now I am going to strip just a little bit of this wire, and this is 22 gauge PTFE, and I'm going to twist it, and I'm going to dip it, and I'm going to butter that up. Now I'm going to probably bring in my helping hands, if I can find a convenient place to sit them where it's going to be in camera view. That looks like it's going to be in camera view. Now this is the wire. I'm going to solder this wire on the center post of this switch. And before I do that, I want to get some heat shrink. And I don't know if I think a small piece will work. I don't remember if the small goes over 22 gauge. Oh, it does. So I'm going to cut a small piece of heat shrink, and I'm going to put my heat shrink on that negative wire, and I might have to feed it into the chassis a little bit there. To get it out of the way enough so I can solder, and then I'll heat shrink my joint when we're done. The other wire is going to be easier because it's going to feed into the chassis when we're done. I don't understand why that shrink doesn't want to. The shrink doesn't want to go down. So I'm going to hold on to it with my needle nose pliers here and shove that shrink on out of our way. There we go. Now I am ready to put this, I'm ready to solder on this center pin to our negative wire, and I'm doing this kind of crazy by hand. And that looks like a good joint. Now I'm going to grab my heat shrink. Hopefully it didn't shrink when I heated up the wire, and I'm going to try and get the heat shrink over this switch pole, which is going to be a tight fit. It is. So now I got my heat shrink on there. I'm going to go ahead and shrink it up. That was the hard one. That was the hard one. Now I'm going to take another longer piece of 22 gauge wire. I don't know that that's going to be long enough, so I'm going to have to go cut another piece of 22 gauge wire. Stand by. 0.9 volts out of the battery. I do like the MHS with the Keystone sleds better than this. They seem like they're going to be more dependable, but we'll see. We'll see how this goes. But on to the next step in prep, which is going to be getting the speaker ready to roll. We're going to do a recharge port on this saber too, right? So I'm not going to use white. I'm going to use black. We'll be running white off our recharge port. So this black wire is actually going to have to be pretty long, because it's going to have to get from our chassis to our recharge port. So I'm going to cut this piece pretty long. Long enough to stick out of the chassis. I actually cut this wire about 18 inches long. It's going to be long enough to stick out of the chassis, but it's also going to be long enough to get up into our recharge port, which I'm putting up in the head of the saber. I'm pretty sure I've decided on a 1.3 millimeter recharge port. I'm going to do a crazy thing in the switch box. Some people may disagree with it, but it's a pretty cool solution, I think, on some of these Ultrasaber and Saber forged hilts that only come with one switch hole. So I pre-tinned my wire. I'm going to add some shrink wrap onto this wire, even though I can feed it from the other end when I'm done, but I'm going to go ahead and use it now. I'm going to put my wire in my forceps. I'm going to reach in here with my helping hands. And the reason I'm going to use the helping hands here is to try and keep this switch from moving around while I'm soldering this wire on here. And this is going to be tight quarters with the helping hands and the camera. Everything is kind of right in my way. I'm going to bend the wire where I need it, and that looks pretty good. Clean my soldering iron off here and get some fresh solder on there. And let's go to town. Little hump of solder there. Shrink won't want to go over that. And that's a good joint. Now I'm going to slide our shrink wrap over that joint, just like that. And I'm going to come back with my hot air rework station, trying not to melt the chassis. Kind of got to be careful when you're using, heat gun around these 3D chassis, because they'll melt. And that's pretty much that. So I'm going to get the helping hands out of the way so I can get in here and work. And I'm going to feed this wire back into the chassis, and eventually I'll be sending it forward all the way to the recharge port. Oops, looks like I tied a knot. I'm eventually going to be sending this all the way to the recharge port in the very top of the hilt. So that's why I made that wire really long. So we're ready to seat our switch now. And then after we get our switch seated and that negative wire back through there, we'll be able to. The only problem is the way I'm wiring this, you'll have to have the switch on to recharge your battery. Because if you have the switch off, it'll actually be, the battery won't have a circuit connected to it. So I typically try not to do that, but that's going to be happening on this one. what can I say? So I'm going to take a little bit of E6000 on either side of that switch, and I'm going to go ahead and drive that switch on home. So really quick, I'm going to show you what I do here. I'm going to put 2 dabs of E6000 opposite of each other on my MHS speaker holder, and then I'm going to drop her down, and then I'm going to press it in on the workbench, and then I'm going to use my thumbnails on the outside edge, not on the speaker membrane, on the plastic outside edge of the speaker, and I'm going to press the speaker into the MHS V6 chassis, and that glue will set in 24 hours, but the speaker stays in there pretty good. But I want to make sure that I have the speaker pressed all the way in, which I do. So now my speaker is installed. I'm going to run my wires through there. Now what I'll typically do is I'm going to add a little bit of hot glue here to hold those speaker wires in place, but additionally I'm going to allow for some slack wire so that the speaker can be replaced at a later time if needed. Alright, it's recharge port wiring time. You know, I really didn't even want a recharge port on this saber, but since we're doing a tutorial here, figured we might as well do a recharge port too. So I have tinned both my 22 gauge red wire for positive, and I have tinned the positive pad on this recharge port, and we know it's positive because we just researched this a little while ago. And that's really not. Let's try. I'm liking that a lot better. And I also know that my cutoff leg, the one that we're wearing, is going to be this one near the middle. So I'm using white wire, and this is long enough to get from the recharge port well past the end of our hilt. Oh yeah, by at least 8 inches. So I'm going to take this white wire, which this wire will be the negative to our soundboard. Remember, the negative we wired from the negative battery terminal is the black wire that's coming up through the chassis, and we won't be able to finish installing this recharge port until we attach that wire. Which, that's bringing up an interesting question. How am I going to get my nut around this recharge port, because the way I ran that wire? We may have to cut the wire and join it, which I don't like doing that, but there is no other way to do this because of the way that we're wiring this saber. The important thing is that you understand how to wire these things. Each saber carries its own engineering dilemmas that you have to figure out. That's a good joint there. Each of these sabers carries its own dilemmas that you've got to work through. Every saber has its challenges. It's good to try to think these through before you build them. And unfortunately, on this one, I didn't really think this through, or I would have recognized this was going to be an issue. Now I'm cutting some shrink wrap, and I'm using some shrink here. I'm going to put it down this wire. I should have put it on before I soldered. Always remember to put your shrink on before you solder. That's always a good rule of thumb. Putting my shrink wrap up over our negative cutoff leg, and now this will be shrink wrap going over our positive leg. And I think, since I do have to cut that wire or join it, I think I'm going to cut a small piece of black wire and actually solder on my black wire on the recharge port so we can go ahead and prepare for install. And then I'll just have to join this black wire and my black wire coming from my chassis. And of course, once I join them, I will shrink them to increase their strength. So I've got a piece of 20, all this is 22 gauge that I'm working with on this recharge port. Anything from the battery recharge port or Neopixel supply lines needs to be a heavy duty gauge wire, either 20 or 22 gauge wire to carry these, to carry the amp loads. Now I'm going to pre-tin my negative post. Bada bing. Now I'm going to grab my forceps and I'm going to hold on to that wire with my forceps and oop, that figures you want to do that, right? And I'm going to bring this a little bit lower so I can brace myself against the table so you don't see how shaky my hands really are. Bada bing, that's a good joint there. You gotta like that. So now I'm going to cut a third piece of shrink to go over our negative port. And the good news is now I will actually be able to install this in the saber, and I think I'm pushing that piece of shrink as far as I can up over that. It's a pretty big nub. That's pretty good. Now let's shrink those up. You can use your iron for this too. I just have my hot air gun here. I also used to use a hair dryer type gun for that. So now our recharge port is wired. Let me get this out of the way. And I don't know if I should install this recharge port yet or not. Stand by. Alright, greetings everyone. So we've finished preparing our chassis for install. There's the chassis, how we left it. Of course, that's not how it's going to look when we're done, but it is all prepared. And it looks like a mess of wires. But we're getting ready to get some more mess of wires. So what I've done is we're preparing to build the hilt adapter, and I've cut 3 pieces of wire longer than the saber because this chassis will go out the aft end of the saber, so you have to cut these wires a little long initially. But the wires that I cut, one red 22 gauge PTFE wire, one black PTFE 22 gauge wire, and I use 26 gauge for data. You can use 30 gauge for data. The gauge really doesn't matter. 26 is a little bit tougher and a little bit easier to solder onto the pads sometimes than 30. 30 can, you know, the small gauge of 30 is a little tricky. I like 26 for data, but it doesn't really matter. I have my custom Saber Shop Neopixel connectors. I also have more pins because these are the 7-pin connectors and I'm going to make them 11-pin. We have our 1-inch hilt adapter, which is going to be going inside the hilt. That's my 1-inch 11-pin adapter. This is also available from the custom Saber Shop. I of course have solder, flux, and for this assignment we're going to need the old helping hands. They help get this done. So here we go. Let's build the hilt adapter. Alright, greetings everyone. Here we go with the hilt adapter. So what's in the bag from the custom Saber Shop when you order these things? You can't order them pre-assembled, but they're actually fairly easy to assemble. So I usually do the assembly of them. And here's where the helping hands come in handy. I'll clip this to my helping hands to help me here, and I'm going to insert these pins into all these holes. And these are the 7 pins that come with the adapter, and of course these are now 11-pin adapters, and I do use 11 pins. More pins equals more amps. I don't know why some of these companies still insist on using less pins. It's always good to have redundancy. It's always good to have redundancy. Now, I have bought these extra pins from Mauser, and I will link the part number so you can buy these yourself if you want them. But they just go right in there like that. So I turn these 7-pin connectors into 11-pin connectors, and you just set these pins down in there just like that. There's nothing hard about building these adapters. Once you, well, if you know how to solder, there's nothing that difficult about building these adapters. Okay, we're back. We got the workspace picked up. This arrow that comes with your TCSS adapter, this target is your blade target. This goes inside your blade. So I'm just going to put that back in the bag until we go to build the blade. Now, I'm not going to build the blade on this video. I already have a series on building the blade, and I ask you to please watch that. So now that I have this ready to go, I'm going to put a little bit of flux on those, and then I'm going to bring in my solder and soldering iron, and let's clean that tip. Nice clean tip. And I'm going to heat up our data pin, and I'm going to put some solder on it, and I'm going to leave the iron there for a second, and then I'm going to withdraw it. I've got a nice clear silver bead of solder holding that pin in now. You don't want to add too much solder because you don't want the solder flowing down into the pin getting caught in the spring mechanism. Just enough solder to cover the head of the pin onto the PCB. These are all the negatives on the middle ring that I'm working on now. I did do one positive there a second ago. If these touch, it's okay because there's continuity between them, so if you're worried about bridging the same ring, you're okay. Now what you don't want touching is this outside ring. And the middle ring, because this outside ring is positive. The centermost pin is your Neopixel data. And now I'm going to pre-tin these pads that will receive our wires. We'll get to that in a minute. And that's it. So the Neopixel adapter is assembled. I'm going to flip it over so you guys can see the underside. There's the underside of the adapter, and I'm going to let that cool, and then we're going to get back to soldering the wires on. Alright, here we go, soldering the wires. So the first one that I do is my data, because it's in the middle and it's kind of hard to get to if you don't do it first. And I'm going to strip enough wire to go from the pad to the actual pin. I actually solder to the pin. So you can see I've stripped back enough wire there to reach the pad and the pin. This is going to be fun soldering this with the camera where I normally have to put my hands, but we'll try and maneuver the helping hands here and see if we can make that work out. So I've pre-tinned my wire here. Now I'm going to grab my forceps, and hopefully my forceps will help me get where my hands normally are. And you're going to see how shaky my hands are. And I'm going to solder to the pin, and then I'm going to solder to the pad. Oops, wire moved on us there. There we go. So that's a good connection on the pad, good connection on the pin. Our data line is done. Next is, you can see it's got a negative side and a positive side. So this side is negative and this side is positive. You can see the minus and plus sign there. So the first one I'm going to do is my negative wire. I'm going to pin this like that. I'm going to strip just enough of my negative wire, which is 22 gauge PTFE. Boom, there we go. And I'm going to give her a twist. I'm going to dip it in flux. I'm going to tin it. Now, what I do at this point is I take my needle nose pliers and I'm going to give this a bend right at the strip mark, right there, just like that. Give it a bend, and you'll see why in a second. I actually cover both pads with my wire. You don't have to. You can go to one of them. I go to both of them. So I'm going to put my handy dandy forceps on here now. And now is where we'll really see my shaky hands pretty bad. So I'm going to, you can see it's covering both pads, and I'm going to heat the solder that I've already placed on these pads, and the wire should melt right in. And it does. Now, the thing you want to be careful with here, the way I do this, is you don't want your negative making contact with the Neopixel, and I'll check that with the voltmeter, but they're not touching. And I'm going to trim the little bit of excess wire there. Now I'm going to put my helping hands on the side we just soldered, and we're going to free up the positive side. So I'm going to take my positive wire. Now I'm going to strip about pretty much, enough to get across both those pads. That's probably a little much, but I will trim it. No worries at all there. I've dipped it in flux. Now I'm going to tin it. And just like we did before, I'm going to use my other set of needle nose pliers and give that a bend right at the point there. Now I'm going to take my hemostats, my handy dandy hemostats, and I'm going to try and pinch them on so I have that at the appropriate angle. I'm going to get this wire out of the way, and I'm going to bring in my positive just like this. And just like we did before, I'm going to heat up the pads. The wire melts down into them. Let the joint cool. Bada bing, bada boom. Now, I'm going to cut the excess wire here, and voila, one Neopixel adapter assembled and wired, and it was quick. Now, I will twist these positive and negatives together, but I don't twist the data line in. Sometimes that causes data line interference if you twist your wires and twist your data line in. So I twist the positives and negatives, but I do not twist the data line. Now, what I'm going to do now is off camera, I have my big tub of isopropyl alcohol, and I'm going to dip a Q-tip in the alcohol. And a lot of wires. It'll neaten them all up, and I'm going to use the alcohol on all of our surfaces to clean them from flux and any other debris. Particularly data. You don't want data anywhere around flux or between flux and negative, or the data and positive and data and negative. You want all those clean and clear of flux. I'm very happy with that. That's a nice, neat adapter. Now I'm going to twist these wires. I'm going to get my data wire out of the way because I don't want to twist my data wire. And these wires are way longer than they need to be. And the funny thing is I think the type of recharge port I'm going to use, we're going to actually combine the positives in the hilt, so this wire bundle won't be twisted like this. Actually, my positive from my recharge port will be twisted into the negative of my Neopixel. And then I have not twisted in the data line. But this makes it the bundle a little bit easier to handle, to take care of. But now what I would like to do is I'm going to use my multimeter and make sure we don't have any bridges that we're not supposed to have. So on my multimeter, this is my tone continuity test. So when you touch the two electrodes, you get tone. And I'm going to touch a positive pad and a negative. And I'm going to touch positive and data. And I'm going to touch negative and data. And again, negative and positive. Making sure I don't have any bridges. And I don't. But now what I'm going to do is I'm touching my positive pad here. Now I'm supposed to have continuity there. Of course, data. Good. And now negative. If I can get my probes to touch the pad, there we go. Good to go. So continuity test passed. I don't have any short circuits there after my soldering. So now we're done with the helping hands. I'm going to set them aside. There you can see our bundle that we've assembled. Now I'm going to take this and stand by because I got to get a small Phillip. Okay, I'm back. Now I know a lot of you are going to want to run the two wires, two red wires and two red wires and two black wires on this. I use 22 gauge, and 22 gauge can carry the amp load of Neopixels, so can 20 gauge. The problem with 22 and 20 gauge wire in standard wire is that the jacket is so much larger. But on these Neopixel wires, the PTFE wires, the jacket is much thinner, but they are 22 gauge. So you can get away with running a single strand versus double strands. That makes it makes that a lot neater. Now, in this 1-inch hilt adapter from the custom saber shop that holds our Neopixel hilt side adapter, this takes the place of the old LED modules. There's two very small Phillips head screws in here, and I am removing those Phillips head screws so we can drop our Neopixel adapter in. There's holes for all the pins, and they line up like so, and you don't want to force it. I might have a pin that's out of alignment or something, so you never want to force that. I'm trying to look at all my pins, make sure they're straight. That's not really wanting to go in. So I'm going to clear all my holes. sometimes the drilling isn't sufficient. There we go. So I pushed my Neopixel adapter in through the holes. Sometimes you do have to clear those out with an X-Acto knife to make sure that they're totally drilled clean. Sometimes they're not. This is a machine part, and then I'm going to tighten those screws down into our hilt adapter. And the funny part is this hilt adapter is easy to set in because the hilt that we're wearing already has a set screw for the Neopixel adapter or the hilt adapter. So this will sit inside the hilt. The blade target comes and makes contacts with these pins. This is your data. This inner ring of pins is negative and this outer ring of pins is positive. So you want to make sure that you've wired those accordingly, and I have. My red is to positive, my black is to negative. Now I'm going to be doing something unique which I don't want to give away, but I minimized the amount of wires running into my chassis, and we're going to be running the red wire into the red wire from the recharge port into the red wire in the chassis that we built, and then we'll be running a single positive pigtail 22 gauge into the chassis to the soundboard. That's a way you can minimize wiring, is join common wires outside of the chassis inside the hilt somewhere. Just make sure that you have a good solid joint and that you're using heat shrink. It's a way to minimize wiring mess. Now some people may also use hot glue in here. I don't, because that way if I need to get to this stuff I can, and the way I build this, that's pretty tough with the 22 gauge wires. I mean, that's pretty tough as it is. So we're going to stop this video there. That is the Neopixel module built. On to the next phase. Alright, so let's wire some switches. Now I had to do some crazy engineering for my second switch here, and that's part of the adventures of building a hilt. This hilt really wasn't designed for a second switch, and I've kind of did some southern engineering there to get it to work out. But you know, the reason that I'm doing all this on this video is I want to demonstrate as many things as I possibly can. I really didn't want to put a recharge port on this saber, but because this is for a tutorial I am putting a recharge port in this saber. So there's going to be two switches on this saber. There's going to be that switch there, and then there's going to be this switch inside of here, inside of this switch box. So right now we're going to wire up both of these switches, and then it will be time to start installing the lightsaber. So let me bring my solder in here, and we're going to pre-tin these switch posts and go ahead and get my wires on there. So if you haven't seen my video on switches, oops, I explain, you know what, I have to bring the helping hands in here for this. So I explained switches a little bit and talked about tactile and momentary switches, and right now this is a 16mm non-illuminated anti-vandal switch. So there's only two poles on it. One pole is for my switch lead and one pole goes to ground. Now I'm actually going to common the ground hilts for both the switches before we install them outside the hilt. So there's only going to be one switch wire, one ground wire for both switches, and that ground wire I'm going to connect into our ground, our negative coming out of the recharge port, and all that's being done in an effort to minimize the amount of wiring. So one thing you're going to find out about my installs is I try to merge common wires before they go to the chassis, because that's less wires running into the chassis, because it doesn't matter. Ground is ground, and if a wire connects it to ground on the board And you can connect to that higher up in the hilt. Why not connect to it higher up in the hilt? There's no sense in taking a gazillion wires back to the chassis. Okay, so this small tactile switch is my auxiliary switch, and I've got a small length of white wire so I can merge my two grounds, and the merge onto my recharge port, which you'll see that once I start doing the install, but the merge onto my recharge port is actually going to happen once we begin the install. So all this will make more sense once I begin the install. And again, you can run all these wires, you know, back to your chassis. I just choose not to. It makes things cleaner, and I'm going to dip this in flux here, and bring in my solder. Sorry. I'm going to bring in my solder, and I'm going to pre-tin this white wire. Now this is my ground wire. So on these tactile switches, which of these poles is ground and which is your switch? It doesn't matter. I like that. So on my switches I use white for ground, and then on auxiliary I always use yellow wire, and then on my main switch I use green wire. That's how I differentiate main, primary and auxiliary switches, is yellow and green wire. That's just how I do it. And you know, my white wire coming out of my recharge port is my negative that goes to my soundboard, and I do it that way because that's the way I learned it from Mad Cow, and it helps me keep it all straight. So these white wires, which are the ground wires on my switches, are actually going to be merging onto my white wire coming out of the recharge port, which is ground. So that switch is wired. Now I'm going to get some heat shrink out, and off camera I have a bundle of heat shrink. I buy it in bulk, and I use this very small heat shrink. I believe this is it looks like 1/16 of an inch heat shrink, and I'm going to cut two small pieces of heat shrink here, and I'm going to put the heat shrink onto our posts. Like so. And now onto the white wire, and I'm going to turn on my hot air rework gun so I can shrink these up. So there's my shrink that's on there, and now we're going to shrink these up. Now typically if I'm sending these wires all the way back to the hilt, I'm going to go ahead and twist these wires, but these particular wires here I'm not going to twist because they're going to go into this hole for my switch and come out of the big hole where I'm going to merge the white commons with the big switch. So this white will be mixed with the white on my big switch, and then they will be joined to the white coming out of the recharge port, and then a single white wire, which is my ground for my switches and my board negative, going back to the soundboard. So now let's wire my 16mm anti-vandal switch. This is my main switch. So I told you my main switch gets the green wire. So now I'm going to strip a bit of green wire here. And I only strip enough to go on the switch pole, and you'll see Here, the advantage of using PTFE wire. From the beginning of the video, I told you why I use PTFE wire. And it's because the jacket doesn't melt back. It stays stripped where you strip it. It doesn't melt back from heat. So PTFE wire from that respect is very easy to work with. There we go. More happy with that. A couple of those joints may have been cold because it shook a little bit, like right before it set, and you know that's a bad thing. So I'm cutting some heat shrink off camera here, and I am going to run a small piece of heat shrink up there, but I don't think that small piece is going to go over that larger post. So I have some bigger heat shrink here that I think I'm going to send over the post. Yeah, this small stuff is not going to fit over that post. There ain't no way. So let me send a bigger piece down that wire. And I cut the heat shrink on a little bit of an angle. And that way it covers the post. Just like that. Now let's do the other side. The other side is my ground. Remember, if you don't know what you're doing here, watch my switch video. These two switches on this saber are not illuminated, so the only two wires on the switch are ground and then your switch signal wire. So the only two switch wires that are really going to be going to the hilt that we need to worry with the way I'm wiring this saber are my two signal wires, the green wire and the yellow wire, which the green wire hooks to the main switch pad and the yellow wire will hook to the auxiliary switch pad. And when you do it, when you see the final install, you'll understand why I'm doing what I'm doing. I'm going to take a smaller piece of heat shrink here and butt it up against that wire before I send the big piece of heat shrink down to cover the big piece down to cover the pole. And then here's my big piece of heat shrink. And that's it. So my switches are wired. There's my main switch. And here's my auxiliary switch. They're both wired and ready to roll. Again, the two common wires on these switches, the white wires, will be joined together. And these two white wires I'll join onto the white wire coming out of the recharge port. So the only two wires that are running all the way through back through the hilt are going to be the yellow and green signal wires. Green for my main and yellow for auxiliary. Alright, so now we're beginning the install process, and now we're going to start installing all these components that we've been soldering up in the last little bits of the video. And now I'm putting my switch wires down through my switch control box for my main switch. And now I'm going to feed the nut for my switch through the wires as well. And the way this particular switch box is designed, and every lightsaber and every switch box is different. And like I said, there is some weird engineering that's having to go onto this saber because of you know, adding this second switch onto here that wasn't, this saber wasn't really designed to have a second switch. So there was a lot of engineering, southern engineering, that went into this switch. But I'm gonna, if I can get this thing to start threading. So sometimes, like, I'm holding the nut with my fingernail, and then I'm spinning the switch so the nut threads on. And it's not wanting to thread. So I'm going to put something in here to stop that nut from threading, from moving while I spin the switch. Not really an easy fix here. I mean, it's spinning on there, but you can still see it's loose there, and it's hard to get. Oh, there. Seems to be going pretty good now. Let me see if I can jam a smaller screwdriver in there and get this thing to tighten up. Give it another twist there to get it as tight as I possibly can. So now that Vandal switch is pretty tight, and what I'm going to do is put a bit of hot glue on either side of that nut, and that hot glue will keep that nut from spinning off, and that's ready to roll. Now, for this reverse crazy engineering job that I had to do over here on this second switch, which, you know, I'm not going to go into detail how I did this. I'm not really proud of this reverse engineering that I did here, but it will work, and it will be strong, and it will last, but because the way I set this up, we'll get this right eventually. Oh, the joys of saber building. You know, this switch is going to be awesome when it's done, but how I had to get it done is a little crazy. Actually had to epoxy a switch seat into the hilt, and I didn't show that. I didn't show a lot of the machining on this saber, because that's not what this video is about. This video is about installing a saber. Now, there's a lot of engineering steps, and every lightsaber is different. So what I had to do on this saber to make this work is not necessarily gonna be on any other saber. I mean, the way that I had to do this to make this work is not easy. And so there's my switch. Now I'm going to be epoxying this switch on, and what will happen when I'm done is this will sit there, and you have the switch you can press there. But we're going to be commenting up these wires. So that's the two switches installed, and I'm going to go ahead and epoxy this switch in, and then I will we'll come back and we'll run the recharge port wires out through here so we can join the positive Neopixel wire to our positive recharge port wire, and we're going to join our negative switch leads to our negative lead coming out of the recharge port, and then we're going to be able to send all these wires down through the hilt. Alright, let's install our recharge port. So I'm going to stick the wires down through this recharge port hole that we've machined into the hilt because it did not have one. Really didn't want to put a recharge port into this saber, but since we're doing an install video and some of y'all have these external recharge ports, I wanted you to see how I wire them up. That's that. Now let's try to send our... I'm actually threading the retention nut for that recharge port over my wires, and now I'm going to send the recharge port home and hopefully start threading the nut inside of here. So it's really hard getting the threads to start, but I think I got it there. So I'm actually using my screwdriver to turn it, and it doesn't want to go there. Yeah, this is always the hard part here. And there we go. The recharge port is in, the nut's holding it down, and we're going to send these wires in through here next. Stand by. Alright, so now that I have the recharge port wired, I'm feeding my recharge port wires into the hilt, and I'm actually going to bring them out of this switch hole. Now you can't do this with all hilts, but with this particular hilt, the way it's designed, I can do a bunch of my wiring in this switch hole before I install my main switch box. So what I'm doing now is getting my recharge port wires all there so I can start that consolidation of my wire process. There's my black wire. So those three wires are the wires out of my recharge port. These two wires are my auxiliary switch wire. And now I'm ready to send my Neopixel adapter in. So I have my Neopixel adapter. I'm going to loosen our retention, and I want my Neopixel adapter positive and negative wires to come into this hole as well. Oops. But I want my data wire to go all the way down through the hilt. So I'm going to try to send my data wire as far as it will go. Hopefully it'll go out the end of the hilt. Oh yeah, it did. So now I'm going to try and orient my Neopixel adapter so it's right side up. It doesn't really matter. And there's my Neopixel adapter installed, and I'm going to tighten the retention screw. Now in some hilts you have to drill and tap a retention screw, but actually on this hilt they provided retention for your adapter right here. So now we got a huge mess of wires there. So these are the two switch wires off my auxiliary switch. These twisted wires are from the Neopixel adapter. And then these three wires are from my recharge port. So I'm fixing to do a merger here, and then as I merge wires I'm going to send them down the hilt. My data wire is already sticking out of the end of the hilt. Now if you'll recall, when we set up the chassis, we set up this long negative wire to merge onto the recharge port negative. So this is our battery negative, and it's going to go to our recharge port negative that I have coming out of the switch hole. So before I install this, because remember I use shroud, and I believe we've already cut a piece of shroud for this hilt. This is the T8 shroud that will eventually go over our chassis like thus. So that'll be covering the soundboard and protecting the soundboard. But before I send this black wire down, I'm going to have to thread our data line through that piece of T8 shroud and put that piece of T8 shroud into the hilt, because if I don't, we won't have the piece of shroud in the hilt. Now, the last thing I have to do for this merge is I'm going to send this wire, this black wire from our chassis into the hilt, and this is when things are going to start to get complicated. Sometimes it helps to tape a lot of those wires out of the way. And I'm looking to see if I see that wire going where I can grab it. Okay, we have a big mess here, and I want to take some of this mess out of the way so it's not confusing people. So number one, I'm going to tape that yellow wire out of the way. I have some painter's tape here ready to go. I'm going to untwist my Neopixel wire, and actually, to avoid a lot of confusion, I may want to send our black Neopixel wire down through the hilt. So I'm untwisting it. Because I'm not, my negative off the Neopixel, this twisted pair here that I'm working on, this came off the Neopixel adapter. And if you'll recall, when we built the Neopixel adapter, we twisted this wire. So number one, I want to get this wire out of the equation because we're not doing anything with it. It's going straight to our negative Neopixel pad. So I'm going to put it through our switch hole here, and I'm going to use my long forceps here, and I'm going to grab it. And I have. So now I've taken that Neopixel wire, and it's now coming out of the end of the hilt. And what I've done is, and I missed it, but I did fish this black wire that's coming off of our, remember we had that long black wire that's our negative that's coming off our chassis, and I pulled my chassis to about right there because that's about where I want it when you pull it out of the hilt. So I'm going to leave about that much wire. This black wire coming out of the back end of the saber is our Neopixel negative. This gray wire is our Neopixel data. So number one, I've got those wires out of the way. Now my yellow switch lead, I want to get it out of the way. And I'm going to bring in my green switch lead because we're going to be doing some work here, and I want this as close to where it's going to install as possible, as if we needed to bring some more ugly wires into the equation. But now I'm going to tape those green and yellow wires out of our way. I actually need that white wire, and I actually need that white wire. So what we have here is what looks like a huge mess. All three of these white wires are going to merge. The two white wires from my switches and the white wire from my recharge port are going to merge, and then I'm going to send a white wire down through the hilt. These two black wires, this wire is from my chassis, battery negative. This black wire is my battery negative to my recharge port. They're going to merge, and I'm going to drop them down in there. Then the last thing I'll do is these two positive lines. This is my positive Neopixel. This is my positive battery from our recharge port. And I'm going to merge these two wires, and then I'm going to splice them onto a long red wire that I will send down through the hilt. This black wire is in its final install place, so when I merge these and drop them down in there, they're going to be out of the way. So I think what I'm going to do is I'm going to go ahead and merge these black wires first. But that's the plan, Stan. That's what's happening here right now. So I'm going to go ahead and put these white wires under another piece of tape because I'll do those last. And I'm going to do the black wires first. And the red wires I don't think are really going to be in my way. I think we're pretty solid there. So let's go ahead and merge this black wire. So it's pretty simple. I'm going to do this merge. I'm going to cut this wire here. I'm going to cut this wire here. And I'm going to get our excess out of the way. Now I'm going to strip some off this wire. This is 22 gauge PTFE. Remember, that's negative coming from my battery and negative coming out of my recharge port, and we're going to merge them. And remember, we had to split this one so we could get my the nut on the recharge port. So that's why I had to do this. This is a difficult part about building lightsabers is, and of course now you guys are really in my way, but you'll see what I'm getting ready to do here in a second. Alright, so now I know I'm going to need a piece of shrink, so I'm going to get a small piece of shrink ready to go here. And I'm going to put, you got to remember to put your shrink wrap on the wires before you solder them, otherwise you won't get them on there. So I'm going to put our shrink wrap on our wire and get it out of the way. Now I'm going to put some flux on those pieces of wire there, and then I'm going to pre-tin them. Here comes the solder. let's go ahead and pre-tin these black wires. Lovely. Alright, so now that I've pre-tinned those, I'm going to get a small pair of forceps and I'm going to clamp on to this black wire. And I got those in my helping hands. So this is why helping hands help, because this gives us the ability to have a free hand. And I want to make sure that my solder is convenient. So I'm going to put my solder in the general vicinity. And you can see I'm test fitting those two wires to see how they're going to go together. I'm kind of digging that. Actually, I want that one back a little bit. It keeps coming with me. Hoping you guys can see this, but if you can't, you're going to see it when my hands get out of the way. So here's our new solder joint here. So I've joined those black wires. Now I'm going to get the helping hands out of the way so I can get our heat shrink up over this joint. And it's very important to cover that joint with heat shrink. Now we're going to shrink up that heat shrink. Over the joint, and that protects the joint from shorting inside the hilt. It also gives that joint some extra resilience. And then I'm going to take my forceps, and that is now a permanently installed wire in the saber, and I'm going to get it out of the way. Next, our positives. So I want to merge these positives about right there. This long positive will come out the bottom of the hilt, and again, one of these positives was from the recharge port and one was from our Neopixel connector. So I'm joining these because they are common wires. They go to a common place on the board. So I'm merging them in the lightsaber. Could you merge them on the board? Sure. Why would you? I don't like taking more than one wire to my soundboard. So I'm going to merge these inside the hilt. Put in some flux on them. I think I need a new thing of flux. That should be on the agenda. Alright, let's pre-tin these suckers. This is phase 1. Actually, you know what? I should have just went ahead and twisted these first. Let's get my forceps in there. Let's twist these together. So I'm going to hold them with my forceps, and then I'm going to twist them together. One wire is partially pre-tinned. That was a little bit of a boo-boo, but it'll be okay. And let's flux to both of them. So now that they're, I'll put it sideways so hopefully you can see them getting tinned. So they're tinned, and that's pretty good there. So now what I'm going to do, I'm going to bring in the helping hands, hopefully in a way that doesn't block the camera. I'm going to bring in these helping hands. I got to clear some forceps out of the way. Bring in some helping hands and try to hold that joint like that. Now I'm going to put my shrink on over our long wire once I get our long wire on. So now I'm going to take that one piece of long red wire that we cut off that was, you know, from the Neopixel feed. I'm going to rejoin it onto this wire. Let's cut that little piece off there. And I'm twisting the wire after I strip it. I'll put the heat shrink on here when I'm done with this merge. And let's tin this red wire that's going to be our long wire going to our red wire that's coming out of our chassis. And then we'll have another join down there where the pigtail joins to go to the soundboard, which you'll see that when I get to wiring in the rest of the chassis. Now I'm gonna, this one's a little bit long, so I'm gonna cut some off of this one and make these joints as short as possible. That's a good solid joint. Now I'm going to take a small piece of shrink to cover the joint, and then I'll take a larger piece of shrink over the whole bundle. I'm hoping this small piece of shrink will go over the joint. If it doesn't, it will just help us cover the bundle in the end. But we'll try and get it up over the joint. Yeah, it's not going to fit over the joint. That's okay. So I'm going to use this somewhat larger piece of heat shrink to go over the joint and over that. These 22 gauge joints can be, you know, sometimes on the large side. So there I've covered that pretty good with heat shrink. And I'm going to go ahead and shrink it up. And again, the heat shrink covers that joint and insulates the joint from shorting. And it also keeps that joint from flexing and breaking. Now, we're through with this red wire, so I can fish this red wire down into my hilt. And I have to make sure that it goes through my clear thing, and it does. So that's that. Now I'm going to push this down into the hilt because that's the final wire there. And you can see the wiring mess we've started with is certainly neatening up. Now our white wires. Now remember, the white wire is the cutoff leg from our recharge port, which supplies negative to our board. That's this 22 gauge white wire. This white wire is the ground from my auxiliary switch. This white wire is the ground from my main switch. So I think the first thing I'm going to do here is I'm going to bring my switch up a little bit closer to its final install point, because we'll be installing this switch box here shortly. And I'm going to go ahead and merge. I'm going to try and merge them about right there. Trying to get this where y'all can see it, but we'll use the helping hands once I get these tied together. And I'm gonna, this is 30 gauge wire. These are my switch leads, so they're not carrying a bunch of amps. Remember, these momentary switches are basically signal wires. All they're providing is a signal. And then I'm gonna strip this 30 gauge wire like that. I'm gonna twist it. Now what I'm gonna do is twist these two 30 gauge wires together. like this, and then I'm going to butter them up with some flux. And then I'm going to tin them. So now our two switch ground wires have been joined. So I have to get those two switch wires to ground, and how I'm going to do that is I'm going to merge them onto our recharge port cutoff leg. So I'm going to cut our recharge port white wire, and now I'm going to strip our recharge port white wire back enough so we can merge it onto our switch grounds. So our switch will receive ground at the recharge port. Ground is ground. Ground is ground is ground. Doesn't matter where it is, if it's on the soundboard or if it's anywhere else. They're all contiguous. I'm not sure which word is right there. I'm going to put the big wire in my helping hands. And then I'm going to get my forceps here. And we're going to grab, and we got to remember, almost forgot. We almost made a fatal flaw. Heat shrink. Always put your heat shrink on before you merge your wires. So I'm going to put the heat shrink onto this bigger wire, and I'm going to try and push it down a little bit and get it out of the way, so hopefully it doesn't shrink up when I do this solder. Alright, now we're back to where we were. Now I'm going to take these two switch ground wires, and I'm going to try and maneuver all of this in a way so we can solder this and do this ground merge together. And actually, I just thought of something. We weren't in panic mode there. Sometimes I forget what I'm doing, because we're going to pigtail this onto a longer white wire to go into the chassis. That's going to be our board negative. So I was kind of getting ahead of myself there. My apologies. I'm not fully caffeinated yet. This is in the morning. Let's try and hold those like that. And let's twist them together with a pair of needle nose. I'm liking that better. And then we're going to solder them together. And now that piece of shrink we put on the white wire doesn't really matter. I forgot. So we merged all those wires together. And now, I don't know if this white wire, oh yeah, that's going to be plenty long enough. You always want to make sure you don't cut your wires too short. So we're going to take the white wire that we initially cut off, and we're going to be putting it onto this merge. So I've stripped the end of this white wire, dip it into the flux. Let's clean that tip. Tip's good and clean. And now I'm going to merge these two wires. So this wire in my hand is the actual white wire that's going to feed my board negative, but it's also how my switches get ground. And I'll prove to you that it works once I feed everything down into the hilt. So this piece of shrink there, it's not going to do us any good. So I don't think a small piece is going to go over that. So let's go ahead and cut a bigger piece of shrink to go over this joint. So I'm going to put a bigger piece of heat shrink over that whole joint like that. And then we're going to shrink that up and we're going to send this white wire down through the hilt. You know, not all installs go like this, just the way this one had this 16mm hole, it made it a convenient workspace to pop my wires out through this hole to do this. On some of these installs you're going to have to send these wires all the way down to your chassis to do this stuff. It was just a way for me to lessen the amount of wires going through everything. So now I'm going to thread this white wire into the hilt. Let me make sure it's inside of my clear plastic tube, and it is. So I'm going to go ahead and pull that wire into the hilt. Now I am free to take my green and yellow wires down and fish them into the hilt. And here they are here. So probably what I'm going to do now is twist these wires together. Because these are my actual switch leads. And then once I twist these switch leads, I'm going to send them down through the hilt and go ahead and install this button. So basically this lightsaber has all been installed. So at this point the only soldering I have left to do is getting these wires into the chassis and soldering on the soundboard. This was the difficult part of the install, all these merges. But the work that I did up here in the top half of the hilt with these merges will make my wiring at the soundboard very simple. And easy. And these wires are going to be way too long. But I'm going to go ahead and twist them because that makes it a lot easier sending all this down through the hilt. Alright, so let's send our switch wires down through the hilt. And this may not be easy because it's getting a bit crowded. We're getting some cram foo going, as they say. I'm looking for, oop, I see him. So I'm going to get my long hemostats, which I showed y'all before, long hemostats, and I'm going to go down inside of here and I'm going to grab those switch wires. That's why those long hemostats come in handy. You can go in there and grab stuff with them. So there's my switch wires going in, which means that we're at a point where we're going to be able to drop that assembly on in there. Now I know you guys are saying, well, shouldn't there be 2 bolts holding that on? Yes, there should. But I used one of the bolt holes for the second switch here, which I still have to do some straightening out on that switch, but I will show you all this for the sake of showing you how all this went together. So we're going to stop there, and I'm going to put this switch together. That's a long clip. Okay, so here's our lightsaber with our switches installed, our Neopixel modules installed. So I can go ahead and put on the head of the lightsaber. We're going to test that switch function here in a second. But what I wanted to do is show you these wires in the bottom of the hilt. Of course, this green and yellow is our switch pairs. Those are our switch signal wires. Green is main, yellow is auxiliary. This gray is our Neopixel data. This white is our board negative. The black here is our Neopixel negative. And the black that's already connected is the negative from our battery negative that goes up into the recharge port. And then if you'll remember, when we assembled the chassis, we had this red wire, and this red wire is coming down from the top of the saber. This is from positive recharge port, positive Neopixel adapter. And what I'm going to be doing is merging it onto this wire and sending one single positive wire into the soundboard area of the chassis. So the last thing we have remaining to do is to go ahead and do this merge, and then all our wires are ready to go into the chassis for wiring onto the soundboard. So we're getting very, very, very close to being done. Very close. Alright. So I've taped all our wires out of the way, and I'm going to go ahead and cut that wire there, and I have that long piece of red wire, which I'm going to use that again here in a minute. And I'm going to cut this wire, I think, about right there. Now, it looks a lot less messy. So what I'm going to do is I'm going to strip this wire, 22 gauge, and then I'm going to strip a piece of our longer pigtail. This is actually going to be our soundboard positive, and I'm actually wondering, oh yeah, I don't need a piece as long as that one, so I'm going to save that piece of long red wire for another project. So I'm going to take this shorter piece of red wire, and this is going to be our pigtail that feeds our soundboard, and I'm going to twist these 2 wires together here. And then I'm going to dip them in flux. And then I'm going to tin them. Good there. Now I'm going to take this wire and I'm going to strip it. And I'm actually going to do something else before I merge these wires. Something that I didn't talk about. I'm going to put a shrink bundle over all of our wires, but I wanted to get most of those wires out of the way before we went into merging these red wires. So let me put a big piece of shrink bundle over all these wires. Of course, it's not going to be able to go over our negative, but we'll be able to get it over all of these. So stand by. I'm going to put a big piece of shrink I don't know if that's big enough or not. That will be big enough. So I'm taking a big piece of shrink. I think this is 3/16 shrink. I'm going to cut a piece of it, I don't know, about yay long. And then I'm going to feed all of these wires through it, including that positive, before I join it down there. So I got my switch wires, my board negative, my Neopixel negative, and my positive that I just cut. We're not going to be able to get that negative wire on there, and I'm going to send that piece of shrink down into the hilt, and I'll show you what I do with that later, but I needed to do it before I did this solder. So I'm taping all those wires out of the way, and now I need to cut a piece of shrink for this merge. So I'm going to get a piece of shrink out to cover this merge, and I think I'm using 3/32 to cover these merges. I'll cut a piece about yay long. That should cover the joint and some of both wires. I think I'll bring in my helping hands, hopefully in a way that doesn't block the camera view. Go. Have some more coffee, Tom. Let's lower those helping hands a little bit. Sorry I had to lower the helping hands. I know I was blocking your view. Now, we're going to put this piece of heat shrink over this red wire, and that's the heat shrink that's going to cover this joint. And we're going to solder this joint. We're going to make it happen, Captain. Don't move on me. I want to make sure that the solder really flows around that joint. That's actually a good joint that could hold up a truck. So let me get that kind of in a position there. And this is our last joint. I'm going to go ahead and heat shrink this. And then I'm going to run this red wire into our chassis where our soundboard goes. She's ready to hook up. And then I'm going to run the white wire into there. She's ready to hook up. And then I'm going to run our gray data line in there. She's ready to hook up. And I'm going to run our two switch leads in there. They're ready to hook up. And then I'm going to run our Neopixel negative into there, and those are all of our wires that are going to be going to the Proffie 2.2. Now, remember that big piece of shrink I put in there? I'm going to bring it back to to about right there, and you can, and I left a lot of slack wire so I can get the soundboard out of here, but right now I'm gonna shrink up this whole bundle. And that'll give some additional strength to that one joint as well. And that black wire we weren't able to get into the shrink because it went straight from the battery terminal all the way up to the recharge port. So there is our chassis ready to go into the Saber. And the wires are a little stiff now, but we'll twist them and they will fit in there just fine. But we are now ready to begin installing our Proffie 2.2. Alright, one last test before I go to install is I'm clipping my negative lead from my tester, and I have my tester in audible continuity mode, clipping the negative lead to my board negative, and I'm going to clip the positive lead onto my auxiliary switch. Now I'm going to depress the switch and I should hear a tone, and I do. Now I'm going to depress my main switch, and my main switch works. So that's my final switch test. Now I am ready to install the Proffie 2.2. Okay, so we've wired our Saber, and we've got all our wires into our chassis, and now the important thing is to prep our board. Now, before we solder any board, it's always good for you to have a wiring diagram. And I'm going to point out some things in this wiring diagram that you've already seen in this video. Number one, the positive from the recharge port and the positive from my Neopixel adapter we have merged, and that red line goes onto this pad. The negative from my recharge port, the cutoff leg, we merged that with our switch grounds, and it's going to go onto this leg. We've done these merges inside the hilt. I'm going to do this merge of these two MOSFETs. Each of these are MOSFETs, and they're basically like micro electronic switches that turn juice on to here. But these can only handle so many amps. One can probably handle the amps of a Neopixel blade, but two certainly can. One would heat up a lot. These often melt if you put too many amps through them. So we try to divide the Neopixel blade negative between these two MOSFETs. So I'm going to bridge these two MOSFETs on the board. Here's an actual Proffie, and I can show you what I'm talking about. I'm actually going to solder a bridge between these two MOSFETs on the board, and then my Neopixel negative line will actually solder onto that bridge, but on the bottom side of the board. My Neopixel data comes off my Neopixel strip. I'm hoping y'all will be able to see this full diagram, but my Neopixel data comes off the Neopixel strip and goes onto this pad. My speakers, which are the blue wires, which we did at the very beginning of the video, they go to these two pads. And my main switch lead goes to this pad, the green wire, and my yellow wire goes to this pad. Those are all the wires we have running through the chassis. You can ignore this part of it because we don't have a crystal chamber. In all actuality, this is a very simple Saber with an external recharge port. It seems complicated when we did the wiring, but you could have actually left the recharge port out of the equation and just wired the positive and negative direct from the battery to the soundboard. But we're going to go ahead and do the bridges on this. so we can go ahead and prepare for install. Now, a question often pops up: do I program this Proffie 2.2 before or after install? And my answer to that is it doesn't matter, but typically I try to program my Proffie boards with some sort of config and program the SD card that'll work with that config before I install. That way, once I get to a point where I can turn on the power, then I have a boot sound and I know I'm rocking and rolling. So I typically program my Proffie boards before I install them. But right now I'm going to go ahead and bridge these two MOSFETs here, and that's the only board prep that you have to do on Proffie 2.2s. I also remove the SD card. You don't want to be soldering with the SD card in there. Alright, so on my Proffie board here, and I've got the wiring diagram right below it, I'm going to bridge these two MOSFETs. And how I do that personally is I use resistor tail. I know some people are going to disagree with this, but this is actually how I do it, and it makes it rather simple. So I've got my piece of resistor tail in there, and I'm going to bring in my clean soldering tip and put some heat on there. I still didn't see a lot of solder flow around that like I would like. Oh, there it went. Blowed that time. And that should be nice and solid. And then after I soldered that one onto that, I'm going to cut off what I don't need, and then I'm going to cut off this resistor there, and I'm going to use my needle nose to bring it up through that pad. Battery died, sorry for the interruption, but I've pulled this resistor tail up through the hole here gently, and basically there you have the bridge. My Neopixel negative will solder onto there on the underside of the board. Now, another question people ask, well, do I put the SD up or down, or do I put the micro USB up? Usually on my installs, I like the micro USB to be up. I'm going to trim off that excess and trim off the excess there. And then I'm going to reflow both of those so they look neater. So now I have completed this bridge, but I've done this bridge on the board. My wire will actually solder onto the bridge there on the underside. So I'm going to go ahead and tin up the underside where my wire is going to go. And now that's ready to receive my Neopixel negative. So that's the only board prep on a Proffie 2.2, and now I'm going to go program this Proffie 2.2 with a config that I have made. If you don't know how to program a Proffie, I have a Proffie config video programming your Proffie 2.2 that I will put down in the links. Alright, we have worked our way back to the chassis, and now I am going to start wiring this saber. The first thing I'm going to wire on this side of the diagram are going to be my speakers. So we're going to go ahead and we're going to twist these speaker wires. And I wonder, yeah, I'm going to eventually I think I'm going to do that. I think I'm going to glue that over there like that. But we'll go ahead and get the speaker wires twisted to hopefully get them high enough to come up that side, and I will try to neaten that up a little bit like that. So it looks like speaker wires are going to be good if we cut there. And now I'm going to strip these back a little bit. Pre-tinning the wires for the speaker. Now, these first two wires are easy because you can just push them up through the speaker holes and they'll be good to go. I think I'm going to bring in helping hands here. Had everything go teeter there on me. I'm bringing the helping hands here to hold the soundboard. Oops, you know what? Had the SD card in there. Don't want to solder with the SD card on. I'll set that to the side and we'll get back to that later. So what I do want to do is I'm going to clip that onto the soundboard, and you can see I've got one speaker wire poking up through there, and I don't want insulation showing. Like that. Of course, you're going to be these little bitty wires, they like to be difficult. Alright, so there is my first speaker pad, and I'm reaching around the helping hands here, and I'm going to touch my soldering tip onto the pad, and then I'm going to release it. Now there's some extra wire there that's sticking up above the solder joint, and I'm going to clip that off and be careful to get it out of the way. And then let me free up my board so I can get my next wire up through. And my next wire is going to come up through this speaker pad right here if I can get it to cooperate. This is where sometimes I use my I'm going to have to here, I'm going to have to use my forceps because this wire does not want to cooperate with us. And then I'm going to break this clip up a little bit. So there is that speaker wire up through there. And the wire's still sticking up through the hole. The insulation is up to the base of the hole, so I don't have insulation sticking out, or I don't have bare wire sticking out below the hole. Dang it, I bumped my helping hands. I'm having to reach around my helping hands here to solder. But that's it. Let's add a little bit more solder to make sure that's a good joint, and then we'll reflow this first one. And that looks pretty good. So looking at my next diagram and my next wire, looks like the next wire is going to be my auxiliary switch lead. So I'm going to separate and untwist my switch leads, and you all remember from the install when I twisted those together. So it looks like our auxiliary switch is our next wire to wire, And I'm going to put the soundboard about where we want it. And it looks like my auxiliary switch wire is this corner piece here, so I think if I cut that wire at about right there, we should be good. You can see I don't have many wires to wire here. That was the advantage of a lot of the work that we did in the top of the hilt, was that we actually made for less work back here at the back. So this should go relatively quickly, but after I solder on this switch wire, I think I'm going to break this into another clip. So now I'm pre-tinning that switch wire. I'm going to clean the tip of my soldering iron, so we're good to go there. This wire is going to come right up through there just like that. And I'm probably going to bring in my helping hands again on a weird angle and try and hold this soundboard in right about there. And my switch wire still looks good. So I'm going to bring in my soldering iron at an angle onto that switch wire, and I'm going to solder that switch wire in. There's a little bit of it sticking out, so I'm going to go ahead and remedy that. And we're good there. Now it looks like my next wire is going to be my Neopixel negative, which my Neopixel negative is going to go on those bridge pads that we made when we were setting up the Proffie for install. So I'm going to, looks like I'm going to probably cut that wire about there. Get that one out of the way. And I'm going to strip just a little bit off of this one. Just enough to go on those bridges. And then I'm going to dip that in some flux. And I'm going to pre-tin it with some solder. And then I'm going to grab it with my probably going to have to this one's going to be interesting. I'm going to solder her onto my bridges. That looks like a really good joint there. And I'm going to try and see if it won't allow me to flex that a little bit, and it will. So coming back from there, it looks like my next is going to be my main switch wire, which goes on this corner. And it looks, if I cut it there, that will be sufficient. You can see there's not many wires left. We have our positive, negative, and data. So this goes pretty quick. There's nothing hard about wiring these Proffies. If you do everything else in the hilt correctly, there's just not much left to do. So there's my green switch wire. This is my main switch, the big one, the 16mm. And now this wire, I'm going to use my forceps to put it up in there. And that is correct. And that looks good. I don't want the insulation coming up there, right there. That is exactly how I want it. heat up the pad. Add the solder. And that looks good. I know it looks good because it's a cone. And cut off the excess wire there. And that looks really good. Now, I am going to wire our main negative. So the main negative is going to go right here. So I can grab that wire and cut it there, and I know we're pretty good. This is 22 gauge, so it's beefy. And I'm going to strip our wire there. Put some flux on there. Tin it so solder doesn't fall on the board. Now I'm going to grab this 22 gauge wire, this big beefy monster, and I'm going to run it up into the soundboard like so. I'm liking that. And now I'm going to solder in our negative. Hands are shaking really bad at the end of the day. Well, oh, duh. It would help if I was holding solder and not the wire, right? I was like, why isn't this solder melting? Because it wasn't solder. It was a PTFE wire. It was my data line. I was trying to solder with my data line. That's pretty dumb. We'll leave that in for comedic value. And then it looks like my positive line is going to be right here. Right there. Battery positive is right there. And it looks like if I cut it right there, we'll be good. And I'm going to strip a little bit of this bad boy. Might strip a little bit more than that. Just a little bit. And then twist those together. Dip it in some flux. Butter up my soldering iron. Pre-tin the wire. Now I'm going to take our positive cable and I'm going to run it up into the battery positive line. I'm going to verify, you know, the battery positive and the battery negative. I double check my diagram, which is right below here, so it's easy for me to refer to, and I'm going to solder this bad boy onto the soundboard just like that. So technically I could throw the spurs to it right now and it would come on, but since I only have one more wire to wire, which is my Neopixel data, and that goes to our third post here. So I want to make sure we have enough wire there to get to that third one. And we do. I'm going to strip a little bit of this Neopixel data, which was 26 gauge. Twist that wire in it. So you can see the actual installing the Proffie is much easier than the rest of the project was. You know, the biggest pain in the butt on this saber was tightening the nut on the recharge cable. I mean on the recharge port. And the switches. You know how I had to design that second switch was actually the hardest part of this saber install. The soundboard is easy. Hell, I think building this chassis with these battery springs was harder than that. And that's it. One Proffie installed. So all we got to do is clean up the wires. Clean up the wires a little bit. Secure that down in there. And we have a Proffie installed. So I'm going to insert my SD card that we took out for the soldering stage. I am also going to clean off the flux from the soundboard. And we'll allow that a chance to evaporate. But yeah, anywhere we might have some flux, I'm going to take that. I'm going to resolder that data wire up in there because it's actually too much raw wire exposed on the underside, so I'm going to push that data wire up in there a little bit tighter. That's another cool part of cleaning up is, you catch things like that. That's better. So now, of course, I have more wire sticking up there. I'm going to trim that off. And we'll dab some alcohol around that. And should be good to go. So I took everything apart again to clean it up. I haven't secured the board in there and I haven't cleaned up these wires yet. But I want to go ahead and reach inside the saber and pull out my shroud to go up over the board, and it'll hold it in there temporarily. This is the clear shroud that went over my board. This is the one I made sure we put in there. And now here is the moment of truth. We've got boot. Let's hit a button. Oh yeah. We are solid. So let's send this hilt home. We're going to send this chassis home. And the first time is going to be kind of tough because it's tight. And then we're going to put the pommel on. And let's reach over here and grab a blade. Turn this light off. See what we got cooking here. Oh man, that's a deep, deep, deep blade socket. Allen key. Just tighten that blade retention. First fire, ladies and gents. Very, very cool. We'll have some work to do on the config to clean up ensure the clash sensitivity is too light because I have it on default, so I know I'm going to have to increase the clash sensitivity, but that will be a work in progress. One Kanan Jarrus Hilt by Ultrasabers installed. We have some cleanup work to do on the final install. We're going to secure the board a little bit better there. I'll show you what I do. So we're going to take this pommel off and we're going to drop this board out and show you basically what I'll do, and I'm going to turn the switch off so I'm not touching it while it's electrified. What we're going to do is we'll secure this proffieboard down. Let me turn the lights back on so you guys can see. We're going to secure this proffieboard down probably with some hot glue, about like that, but I'm not going to do that until I finish meshing with the the config file and make sure that my final programming is good. So right now that, you know, our clear shroud that we have in the hilt can hold the board down just fine. And I'll do the rest of the cleanups and securing the board into the chassis, and I'll clean up these wires here. I think I'm going to send this wire over to this side, and then we're going to be golden. So this lightsaber is done. Thank you all for coming along for the ride, and don't forget, if I can do this, you can do it. But that is one lightsaber fully installed, and I'm very happy with the results. And the switch works. I wonder if the recharge port works. That's one thing we haven't tested. Let's see if we get the recharge port noticing anything. I'm going to plug in my recharge port. Now I'm going to plug in my smart charger. Oh, you know what? That's not going to work. Because remember we said you have to have the switch on to recharge the saber. So let's turn the switch on. Funny thing is, you'll rarely have to turn this off because it's Proffie 2.2 and the standby time is pretty incredible. I think you'll rarely, if ever, need to crack this saber open anyway because it's got a recharge port, so you can just recharge it. So here we go again. So now that the battery switch is on, we're going to plug in our charger. This is my charger, and I'm getting ready to plug it in. And you can see right now it's testing. Bam! Charging! Ha ha ha! Everything works. I am so proud of this. Thank you everybody for coming along for the ride, and you know, this saber will be for sale soon. Everybody stand by. When I finish cleaning it up, this lightsaber will be for sale. Thank you everybody for watching. May the Force be with you, or the dark side as it were. Don't forget to expand the information box below for all the links.